Hello everyone. Today let's discuss about surface tension. So what is surface tension? Various books have given various definition for surface tension. Here I'm going to explain you what is surface tension in a simple manner. Imagine a liquid. So imagine a water. Water will be having a surface. The outside part of the water is called the surface and the inside part of water is called bulk. Now we consider inner part of the water. So here bulk molecule, if you consider this molecule, it is experiencing force in all direction. Therefore, the net force of attraction on this molecule will be zero. So when you come to the surface molecule, for example, we consider this water molecule in the surface, there is a sideways force of attraction, so which is opposite to each other. Therefore, the net sideways force of attraction will be zero. And there is a downward force of attraction, so and the net resultant force of attraction is downside, and there is no upward force of attraction. So there is no upward force of attraction and sideways force of attraction has been nullified, and the net resulting force will be towards downside. This downward pull creates this tension at the surface of the liquid, and this tension is called surface tension. The inward pull of the surface molecules by the bulk of the molecules causes a tension on the surface, and this tension is called surface tension. Now, what are the consequences of surface tension? One of the consequences of surface tension is the water droplets are spherical in shape. Why is it so? All the water molecules at the surface are experiencing a inward pull, and because of this inward pull, all the water molecules wants to come inside the bulk. All the water molecules wants to come inside from all the direction. What it would result? It would result in a sphere. That's why water droplets are spherical in shape. So water, if there is no container to support it, so water will be having a spherical shape. And also it is important to note that since all the water molecules on the surface wants to come in, so water wants to always have minimum surface area. It always wants to have a minimum surface area, and sphere has a minimum surface area. So that's the reason why water droplets are spherical in shape. Now imagine this crazy scenario. Imagine a square shaped aquarium. So in 3 dimension it will be a cube. Now we remove the glasses from all the sides. So there is no support for the water. So water was having a cubical shape because the container is of cubical shape. Now we have removed all the glasses. Will the water will stay in the form of cube? No. Because of the surface tension, the water would form a sphere because it wants to acquire a minimum surface area because of surface tension. So this is the reason why water droplets are spherical in shape. One of the other consequences is small insects or small objects can float on the surface of water. For example, water strider or any small insects can walk on the surface of water. As you can see in this picture, a small pin, if carefully placed, can float on the surface of water. Why is it so? It's all because of this surface tension. To understand this, let us take up a model. So here it's a balloon and it's being stretched by applying opposite forces. As you can see, so force is being applied in this direction, force is being applied in this direction. Therefore, two opposite forces are acting on this balloon. Therefore, this balloon now is behaving like a stretched membrane or stretched film. So, for a thing to be stretched, for anything to be stretched, two opposite forces should be acting. Then only it will be stretched. Now, this balloon, we can call it as a stretched film. Now, the same concept we apply to the water. So, let's see this. You see the image here. So, all the circles representing a water molecule, there's a applied force from the top by the insect. So insect when sits on the top of surface of water, so it puts pressure on water molecules. So what will happen? Water molecules will go down. As you can see here, the red circle represents one of the water molecule which has gone down. Now will it stay down? No. What will happen? The adjacent water molecules wants to pull back this water molecule which has gone inside. So what is happening? Insect is applying pressure from this direction. At the same time, there is an opposite force that is applied by the neighboring water molecules. Therefore, two opposite forces are acting. Therefore, what will happen to the surface? The surface would act as a stretched membrane. Now we have established the water surface is behaving like a stretched membrane. When force is being applied from the top from any small objects like insects or pins, the opposite force is generated by the neighboring water molecules. So therefore, there are opposite forces acting on the surface of water. Therefore, water is behaving like a stretched membrane. Now, what if we break the force of attraction on the surface of water? When this force of attraction from the neighboring molecule is broken, the object would sink. How is it so? For example, if we carefully place this pin on the surface of water, it will float. Instead of placing carefully, if we simply dump the pin will have enough kinetic energy to break the neighboring force of attraction on the surface of the water and it eventually sink. So if we just drop the pin, it has enough energy to break the surface molecules force of attraction. So everyone, this is all about surface tension. You learned about surface tension and what are the consequences of surface tension. I hope you understood. So I'm going to see you next time with another concept. Thank you.